Okay, we worked on an activity today in class in groups, and these are some notes just to summarize what you learned today. So the standard deviation is just a measure of how spread out the data is. It tells you on average how spread out the data is. So the first thing when you have a distribution that you need to find out is what's the mean. And if you remember, the mean is the balance point. So in this dot plot, it's really easy to see the balance would actually be at 4. So the mean is 4. And then what you want to do is figure out how far the observations are from that mean. And when you do that, you kind of see we've got 1 away here at 5, you've got 2 away here at 6, you've got 1 away again at 7. So on the right side, it's roughly 2 to the right. Same thing on the left side. So I'm going to say the standard deviation is roughly 2. So we'll say the standard deviation is approximately 2. Now you'd want to put units. We don't know what the units are here, so we'll talk about that some more. But on average, the observations are 2 units away from the mean. So on average, the observations are 2 units away from the mean. And we're going to learn there's actually a formula. So this was just an approximation just to give you an idea as to what the standard deviation really is. So to sum it up, the average overall spread of the data points around the mean, and S, which stands for standard deviation, has the same units as the data and also the mean. The mean would have the same units as well. Okay, so what are some similarities and differences between the range, IQR, and standard deviation? So the similarities would be they are all measures of spread. And then the difference would be that they, the IQR is the only one that is a resistant measure. So IQR is a resistant measure. Of spread. Now, why would that be the case? That is the case because IQR is only the innermost 50% of data. So if you have skewness or outliers on either end, on either tail, that will not impact the IQR. Maybe a little bit, but it won't be a drastic change. So underneath this, say IQR is only the inner 50%. And therefore not impacted by outliers or spread. Or skew, not spread, sorry. Okay, now the range and standard deviation are not resistant. So range and in just a minute, I'll summarize exactly when to use which one of these measures. Now, one thing to make sure that you recognize is they all do use the same units. So they all have the same units as the data. Just like the mean and median and mode would as well. So similarities are they are measures of spread. They all have the same units as the data. The differences between them are that IQR is the only one that is a resistant measure of spread. Range and standard deviation are not resistant. So how do we actually calculate the standard deviation? So let me kind of scroll down here. And there is a formula, and it is on your formula card sheet, so you might want to take a look at it. So I'm going to present it to you just like I did with the mean. It's going to look kind of complicated, but it's not really hard to use at all. So S sub x is the symbol we use, and what this stands for is you're looking at the standard deviation of your variable x. So of variable x. And then the formula is simply going to be the square root, and you are going to sum, remember we talked about the summation symbol, and it's every x, so remember we talked about I for iteration, so every iteration of x, that just means every x, subtract the mean, you square that difference, and then you would divide by n minus 1. And we'll talk some more about degrees of freedom later, but this standard deviation has degrees of freedom of n minus 1. And I do want you to look at the formula card. And every time we introduce a new formula, I will ask you to do that because it's so important that by the end of the year you know where to go on the formula card to remind yourself of the formulas. Now, what is variance? Variance is really just the standard deviation squared. So it's really just going to be what's underneath the radical, the square root sign. So it's just this part right here. So it's what you get before you take the square root. So that would be your variance. And we really only use variance in an effort to get your standard deviation, so sometimes you will have that. You do need to know what it is because you will be given multiple choice questions where it talks about the variance and you need to understand the relationship with the standard deviation. But the important thing is to know how to find your standard deviation and what it means. There is one section of the book when we do some transformations of data and combining of data when variance is important. We actually use that, and we choose to use that over the standard deviation. So we'll talk about that later. So what are some key characteristics of standard deviation? So let's talk about that. Your standard deviation is always greater than or equal to 0, always. There are no options. You can never have a negative standard deviation. It's sort of like a negative distance. That wouldn't make sense. If you have a standard deviation that is equal to 0, there is no spread and all the observations are identical. So S is influenced by outliers and skew. We already talked about that. Making S a non-resistant, that's what we call it, measure of spread. So it sounds like it has a lot of weaknesses. When do we use it? Is it important? It actually is very important, and we'll actually use S a lot this year. So it's most meaningful and used most frequently when you have data that is symmetric. So data with a symmetric shape. So in that case, you would use S and the mean. They kind of go together. So S and X bar go together for distributions that are not skewed and have no outliers. So just so you understand how to actually compute standard deviation, we're going to do something together real quick. So let's go ahead and go down to the next little section. And the first thing we need to know is we need to know the mean. I'm going to write all this out, just kind of showing you what I'm thinking here. You're just going to add all 5 of those together. and divide by 5 to average. Take the numerical average, and you are going to get 41. So that's the first step. The second step, and when you have this limited amount of data, you can sort of just set it up all in one step. So I'm going to show you S of x is equal to, and then I'm going to use my square root symbol. And I know I need a division in here. And then because n is 5, I divide by 4. That's the degrees of freedom. And we'll talk about that a little bit more, but it's not something you really need to know except the term degrees of freedom. Just means you subtract 1 from the number in the data set. So I'm going to take my first observation, 0 minus 41, I square it. My second observation, 25 minus 41 squared. So I'm just following this process. You know how we talked about some of you know how to find the mean absolute deviation? You've learned to do it in prior math classes. It kind of feels similar to that. So this would be 90 minus 41 all squared. And then what I get is, when I do the division, I get 1,205. So the variance here, just to point this out, is equal to 1,205 minutes. But the standard deviation, just making sure you see the symbol, the standard deviation is going to be the square root of that, which is just going to be 34.71 minutes. All right, so that's how you do it. On the calculator, it is underneath 1-bar stats, and it is the one that says S of x, just like this. You'll see a symbol that also says it's your actual sigma symbol sub x, and that's a population standard deviation. And we're going to learn more about that. For now, we are really focusing on your sample standard deviation. So what factors should you consider when choosing summary statistics? So this is sort of to wrap up, how are you going to describe your quantitative data using numbers? So if your data is symmetrical, then you know that your x bar, which is your mean, and your median are pretty much the same. So in that case, you'll use x bar and you'll use standard deviation. So you use mean and standard deviation to describe it. These go together, and the way that you can remember that is you have to compute x bar, and it's part of the formula for finding S sub x. So one way to also think of it is, you know the mean is not resistant, therefore you know standard deviation is using that mean is also not resistant. So if your data has outliers or skew, then you will use the median and IQR. So these two kind of go hand in hand as well. Think of the median, it's right in the center of your IQR, so you know they kind of go hand in hand as well. And these are more resistant to outliers and skew. And then you are going to work on assignment number 6. And I would suggest, since we have a long weekend this weekend, if you want to get ahead, go ahead and start the review. This would be Tuesday night's homework, I believe it is. And you could even do the practice test. And then just make sure you're working on your flashcards. These are not actually assigned. The review's Tuesday night, I think, and the practice test is Wednesday night, but that way you can get ahead and not have such a stressful week. And then the flashcards you have already been working on, or you could do it as a great review over the weekend as well. So that gives you plenty to look forward to. Make sure to do assignment 6 because that definitely is due on Tuesday. Y'all have a great weekend.